All right, let's jump right in. Think about expanding and condensing logarithms, like playing with Legos. Expanding is like taking a complex model and carefully breaking it down into all its individual pieces. And condensing, well, that's just the reverse, clicking all those pieces back together to build one single solid structure. Today, we're going to master both sides of that coin. So here's our game plan for today. First, we'll cover the 3 core rules that are the absolute foundation for everything. Then we'll get our hands dirty with expanding. And right after that, we'll tackle condensing. I'll also point out a couple of common mistakes you'll want to avoid, and then we'll wrap it all up by showing you exactly why this skill is so crucial for what's coming up next in algebra. You know, everything we're about to do, whether it's breaking logs apart or building them back up, it all comes down to just 3, that's right, 3 fundamental properties. Once you get these down, you've got all the tools you'll ever need for this stuff. Okay, check out this table. This really shows how logarithms are a two-way street. The product rule tells us that multiplication inside a log turns into addition between logs. The quotient rule, well, that turns division inside into subtraction outside. And the power rule, which is super useful, lets us take an exponent from inside the log and just drop it down in front as a coefficient. These 3 moves are pretty much the whole game. So, let's get started with expanding. This is where we take one big, messy, complicated logarithm and we carefully break it down into a nice, clean sum or difference of simpler logs. We're basically using our rules to deconstruct the expression piece by piece. All right, here's our first example. We need to fully expand the logarithm of x cubed times y, all of that divided by z squared. Now there's a definite order to this. We're going to handle the division first with the quotient rule, then the multiplication with the product rule, and we'll finish up with any exponents using the power rule. First things first, let's look at that main fraction bar. That bar means division, right? So we bring in the quotient rule. This lets us split that one log into 2 separate logs with a minus sign in between. It becomes log of the top minus log of the bottom. Easy enough. Okay, on to step 2. Take a look at that first term, log of x cubed times y. See that multiplication in there? Well, that's our cue to use the product rule. The rule says we can split that into the addition of 2 different logs. So we get log of x cubed plus log of y. And that minus log of z squared, it just comes along for the ride. And now for the final step, we get to use the power rule. You see those exponents? The 3 on the x swings down to the front of its log, and the 2 on the z does the exact same thing. And what about log of y? Well, it doesn't have an exponent, so it stays just the way it is. And there you have it, our fully expanded expression. Whoa, hold on a sec. Before we move on, let's talk about something that's absolutely crucial. You are going to see roots inside of logarithms. A lot. The key, and you have to remember this, is that a root is just a sneaky way of writing a fractional exponent. The square root of x is really just x to the 1/2 power. A cube root is the 1/3 power, and so on. You've got to make that switch before you can use the power rule. All right, let's switch gears. Now we're going to talk about condensing, which is all about building things up. We're going to take a bunch of simple log terms and combine them all into one single, compact logarithm. And how do we do it? We just use our 3 rules, but this time in reverse. So here's our problem. We need to condense 2 times the natural log of a plus 1/3 times the natural log of b minus the natural log of c. We're literally just going to work backwards from what we did when we expanded. So first we'll deal with the coefficients, then the addition, and we'll finish up with the subtraction. First step, we use the power rule in reverse. All those numbers sitting out in front of the logs, they're going to move up and become exponents on the stuff inside. So that 2 hops up to become a power on the a, and the 1/3 moves up to become a power on the b. Next up, let's handle that addition sign. Using the product rule backwards tells us that if we're adding 2 logs, we can combine them into a single log of their product. So we merge the natural log of a squared and the natural log of b to the 1/3 into one single term. And now for the final move. We have a subtraction between 2 logs. The quotient rule lets us condense this into a single log of a fraction. The positive term goes in the numerator on top, and the term that was being subtracted goes in the denominator on the bottom. You can also see we turned b to the 1/3 back into the cube root of b, just to get that really clean final answer. Okay, listen up, because this part is really important. Knowing the rules is great, but knowing how to avoid the common traps is what will really make you a pro. Let's look at 2 of the most frequent mistakes so you can sidestep them when you're doing your work. Oh man, this is such a classic mistake. If you have a number sitting outside of parentheses, you have to
have to distribute it to every single term inside. It's so tempting to just give it to the first one and call it a day, but that's wrong. As you can see on the right, that 2 has to be multiplied by the log of x times and by the log of y.
And the second major pitfall is all about order. When you are condensing, you absolutely must move those coefficients up to become powers as your very first step. If you try to combine the addition or subtraction first, you're going to group things wrong, and I guarantee you'll get the wrong answer. Power rule first, always.
So you might be sitting there thinking, okay, that's a neat little math puzzle, but why do I actually need to know how to do this? Well, this isn't just some random exercise. This skill is actually the key that's going to unlock the next major topic in algebra for you.
And here it is, the big reason why this all matters. Pretty soon, you're going to be staring at equations that have multiple log terms all over the place. And here's the secret. You can't solve them like that. You first have to use your condensing skills to combine all of those messy terms into one single clean logarithm. Only then can you actually solve for the variable. It's not optional, it's a required step.
So there we have it. We've learned how to deconstruct and reconstruct logarithms, how to change their form without ever changing their value. You now have the foundational skill. So the only question left is, now that you can rewrite them, are you ready to solve them?